Hello guys, welcome to lesson 3 of chapter algorithm. Today we are going to look at algorithm control construct. Okay, let's proceed. A control structure is a fundamental concept that governs the order in which a set of statements is executed within a program or an algorithm. That's a control structure. It basically analyzes and chooses in which direction a program flows based on certain parameters or conditions inside any other construct. There are three different types of control construct. Now, before we proceed, let me take different cases for you guys to understand better. For example, if I want to calculate the sum of two numbers, I will ask for the first number, I ask for the second number, I add them, then I give the result. But in case I need to determine if a number is even or odd, after getting a number, there is a comparison I have to be doing. After doing the comparison, that is to know if the number is divisible by 2 or not. From there, I will output even if the number is divisible by 2 and odd if it is not divisible by 2. So you see in these two cases, we have different type of control structure because in the first case, there is no condition that I was doing. I was simply taking the first two numbers, I add and I display and I'm done. For the second case, I am taking a number. There is a condition to be made whether the number is divisible by 2 or not. In case it is divisible, there is an output I am making, and in case it is not divisible, there is a different output I am making. That is it. Another one is, for example, in school, we know that for you to move from one class to the next higher class, you need to pass your exam. And if you don't pass, you will repeat the class in which you are. So you will keep on writing exams until you succeed. That is how it is. Because if you're in Form 5, for you to get to lower seat, you will need to be writing the O level again and again until you pass or you withdraw from school. So this is different from the first two cases because in this case, we are doing the same thing again and again and again until a particular condition is met. That these are the three different cases we have in all algorithms. And we can have an algorithm having these three cases at the same time. We can have the algorithm having one case in the other. And this is what we are going to see. The first one is the sequence control structure. The sequence construct is a linear progression where tasks are performed sequentially one after another. The actions are performed in the same sequence, top to bottom, in which they are written. That's the sequence control structure. That's case one. That is, we execute one by one in the manner in which they appear. So in pseudocode, this is how a sequence control structure is written. We have statement 1, statement 2, right up to the last statement. And when we are executing, we execute statement 1, we execute statement 2, we execute the others until we arrive at the end. In flowchart, this is what we have. Statement 1, we have our flow line moving to statement 2, then we have our flow line moving to statement n. That is how sequence control structure is being depicted. Like I was saying, I take the first number, I take the second number, I perform the addition, I display the output one after the other, the manner in which they are appearing. The next one, the selection or the conditional control structure. Selection is a programming construct that allows a program or an algorithm, if you want, to run or to be executed to run a set of code depending on truth value of a condition. So in this case, we are executing a set of instructions based on the truth value of a condition. The selection logic is depicted as we have if then else and if, or we have the select and select structure. So these are the two structure we have for a selection control structure. Either the if then else and if or the select and select. Okay. A. If and if statement. This statement executes a set of instructions if the condition is true. In case the condition evaluates to false, the program flow moves to the statement directly after the if construct. In pseudocode, this is what we have. If we evaluate this condition, if our condition is true, then I will execute these statements I have here. But if this condition is not true, I jump. That is from here, I jump directly here and I continue my execution. That's how it is. In flowchart, when we enter into the condition, if our condition is true, what should we do? We execute this statement. If our condition is false, we don't execute any statement and we proceed. As said last lesson, the use of this circle, you realize that at this diamond, we are diverging. We have one arrow, we have one arrow. But after executing this or not executing at all, we must proceed. And that is the use of this one. It combines these two diverging flows to a common point, which is this one. So as we are saying, on a flowchart, after executing the condition, if our condition is true, yes, we execute this statement, we end. But if the condition is not true, no, we proceed directly and we move. B. The if else and if statement. This statement executes a set of instructions if the condition is true. In case the condition evaluates to false, a different set of instructions are executed. So it is different from the first case because in the first case, if our condition is not true, we proceed with the flow of execution. But here, if our condition is not true, we execute but a different set. And the pseudocode is what we have. If condition, if our condition is true, then I will execute block A. Else, I will execute block B. So that here there is no else because here we execute this statement if this condition is true. Otherwise, we jump and we move. But here, if my condition is true, I execute block A. This else means my condition is not true, and in that case, I will instead execute block B. Visually on a flowchart, this is what we have. If condition is true, that is yes, I execute block A. If condition is not true, that is no, I will execute instead block B. At the end, we come and we merge here and we proceed with the flow. So that's the difference between this and this. Because when a particular problem is being described, it is very important for you to know which of them you are to use. C. Nested if. Sometimes the use of if else by themselves is not enough. When your first condition evaluates to true or false, you might want to ask another question or check another condition rather than using the else option immediately. This builds what is called nested if statements. So in this case, we are using nested if. The word nested meaning and something into something. A nested if meaning an if condition into another if condition. And here it is being used where the truth value of a particular condition brings you to another condition. Let me take, for example, the root of a quadratic equation. If my discriminant is 0, that means equal root. But now if the discriminant is not 0, what does it mean? It can either be greater than or less than. In case it is greater than, so I will ask the question again, is the discriminant greater than 0? In that case, real root. Otherwise, I have another alternative. So these are some of the cases you mean. A condition whose truth value brings you to another condition that will call nested if. In pseudocode, this is what we have. So as you can see, if condition 1, then I execute block A. Else, meaning condition 1 is not true. If, so I have another condition again, that is if condition 1 is not true, then let me try condition 2. If condition 2 is true, I execute block B. Otherwise, I execute block C. That is what we have. So we have this particular if inside this one that we call nested if. But now this can be summarized as this, that is if condition 1, then I execute block A. Else if directly condition 2, I execute block B. Else I execute block C. And if, so this block and this particular block are the same. In flowchart, this is what we have. If condition 1, so if condition 1 is true, I execute block A. If it is not true, I come and I try condition 2. If it is true, I execute block B, and if it is not true, I execute block C. and from there I proceed with the flow of execution. Like I was saying, I can. If is my discriminant 0? Yes. Equal root, I continue. Is my discriminant 0? No, I come and I ask another question. Is the discriminant greater than 0? Yes, reroute. No, complex root, and we proceed. This is what we call nested if statement. Good. So these are some of the cases we have when it comes to the if then else and if structure. We have a simple if and we have if else and if, and we have a nested if statement. And based on the different questions that we are going to see, we are going to see the particular type to use. The select statement. The select one of the control structure that simplifies. The select statement is one of the control structure that simplifies decision making in your program. It provides an efficient way to evaluate an expression and execute different blocks of code based on the value of that expression. This can be especially handy when dealing with a large number of branching conditions. It is also called switch, match, or inspect statements. So the select statement here is somehow like a nested if, but here it matches when we have different values corresponding to different input. In pseudocode, this is what we have, that is switch variable. Case if I have value 1, if this variable has as value 1, then I will execute block 1. If it is value 2, I execute block 2 until for the different cases for value n, I will execute block n. Now this default means what? I will execute this block D if and only if all the different cases do not match with the value of my variable. For example, if this value is 6 and I have 5 cases, that is for 1, 2, 3, 4, and 5, and the value of this variable is instead 6, then it is block D that will be executed. So in case the value of this variable does not match with any of the different cases, then it is the block of the default that is going to be executed. For a flowchart, this is what we have. Variable is equals to value 1. Yes, I execute block 1 and I end. It is 2. I execute block 2 and I end. If it up until when it is n, I execute block n. So now for this last condition, if this last condition is not true, then I will execute block D as the default. Look at something. For me to come and compare for variable 2, for value 2, this one needs to be false. For me to arrive here, this one needs to be false. So I will arrive only at block D only if all these different cases are false. That is why it is called the default. Good. This difference between select statement and nested if statement is that select statement makes comparison with discrete values only and not range of values like the nested if statement, which can also make comparison with discrete value. So you see that in this case, the select statement goes with discrete values only. That is 1, it can be 2, it can be 30, it can be 40, only specific values. Whereas the nested if goes with other types of values, a range of values, like for example, is it greater than 0, is it greater than 5, is it less than 10, as well as we can still make use of discrete value. So a nested if makes use of both ranges and discrete values, whereas select statement only makes use of discrete values. Otherwise, all select statement can be implemented using nested if statement, but the reverse is not true. So that is what we have. E.g., if the possible values are 1, 2 until 7, like days of the week, we can use both statements. But when it comes to grades, where ranges are equal like 100 to 90 for an A grade, 89 to 79 for B grade, and so on, only the nested if statement can be used. So guys, I hope now you have a better idea about the sequential and the selection control structure. In the next video, we shall be fully talking about the last type of control structure, and I hope you might make research and know which last type of control structure we did not make mention, which we are going to fully explain in the next video. Do not forget to like, to subscribe, and to share. See you in the next video.